Hello students, welcome you all to a session regarding discussion on the steam tables. Already we have discussed regarding the formation of steam at a constant pressure, and when this steam is formed at constant pressure, we have discussed the various properties, that is the specific enthalpy, specific internal energy, specific volume, as well as the specific entropy also. So all these properties, they have been recorded for the steam formed at different pressures, and they have been tabulated systematically in a table. So this table where all these properties which have been tabulated systematically in a table, we call it as steam table. So in today's session we will be discussing regarding how the various properties of the steam, they have been extracted from the steam table, and how they can be used for solving the problems for the formation of steam. So as we go on to the next slides, we'll be discussing regarding how we are extracting the properties of the steam from the steam table, and which are the different properties which are available in the steam table. Now, as I was telling you, the first important thing is regarding the nomenclature which is coming in the steam table. So any steam tables which you take, these are the common nomenclature which are present in the steam table. So always the first column which you are observing is, it may be temperature, which is in terms of degree Celsius, or it may be a pressure in terms of symbol P, and this pressure value in some steam tables, its values are written in terms of megapascal or even in terms of bar. So in some steam tables, they are writing the pressure value in terms of megapascal, and in some steam tables in terms of bar. So when they are writing in terms of megapascal or bar, you should know what are the conversions to be done from megapascal to bar or from bar to megapascal. So just a simple relation, I will write it here. So generally, what is the value of 1 bar? So 1 bar, it is nothing but it is equal to 10 raised to 5 Pascal. So 1 bar, it is nothing but it is equal to 10 raised to 5 Pascal. So now what is the value of 1 megapascal then? What is the value of 1 megapascal? It is equal to 10 raised to 6 Pascal. Which means if I want to convert megapascal to bar, then what happens here now? 1 megapascal is equal to how much now? Here it becomes 1 megapascal is equal to 10 into 10 raised to 5 Pascal. 10 raised to 5 Pascal, or which means 1 megapascal is equal to, what is the value of 10 raised to 5 Pascal, which we have already written here? It is 1 bar. So what it means, 1 megapascal is equal to, it becomes 10 bar. So this is the conversion you need to remember. So in some steam tables, they have written the pressure values in terms of megapascal, and in some steam tables, they have written the values in terms of bar. So many times when the question is given for you in the examination, maximum times the pressure value will be given in that bar itself. So the important thing is you should check what are the values of pressure given to you, are they in megapascal or bar. If they are given in bar, no need for conversions, you can go for directly. So as I was telling you, if the values of pressure are given in terms of megapascal, you have to convert that into bars. Or if in the steam table it is directly in the bar, then you don't need to go for any conversions. You can directly pick the values and do the respective calculations. So always I repeat, when you are referring to the steam tables, especially for the pressure column, you have to check whether it is in terms of a Pascal or it is in terms of bar. This is the care you need to take when you are solving the problems. Now, coming back to the next important thing is, other than these particular properties, which are other properties which you need to refer. So as I was telling, once you have the pressure and temperature, once you have the pressure and temperature, the other properties which you may observe in the steam table is the specific enthalpy, which is designated as small h, and its unit is in kilojoules per kg. Similarly, we have specific entropy, it is S, and its unit is kilojoules per kg Kelvin. Already discussed. The value of temperature is symbolically written as T, and its unit is in degrees Celsius. Then we may have in some steam tables, he has given this specific internal energy, or it may not be given. So even if he has not given, you can calculate using the relation which I will tell you later. So the specific internal energy, which is represented as a small u, its unit is also in terms of kilojoules per kg. And the another thing is a specific volume, small v, its unit is metric cube per kg. So this particular property, that is the specific internal energy, it is available in some of the steam tables. These values are available, and in some steam tables these values are not available. So when they are not available, how you can get these values? So you have to use one equation. That equation is H, small h, that is internal energy, specific internal energy. H is equal to U plus PV. So if you use this relation, that is already H is available to you in the steam tables, even pressure P is available to you, even V, specific volume V is available to you, then you can calculate even specific internal energy. So you don't need to worry. Even if this specific internal energy is not available in the steam table, you can calculate using this particular equation, that is H is equal to U plus PV. Then apart from this, very important thing is, for all these properties we are having some subscripts. So already we have discussed regarding the subscripts in your theory classes. So just I will brief you once more. So whenever the formation of a steam occurs, already we know that it gets transformed from the that is the fluid phase to the vapor phase. So the fluid phase, that is the saturated liquid, it is represented by a subscript known as F. So if a fluid it is present in the, sorry, if a steam is developed in a fluid phase, then subsequently its properties, that is a specific internal energy, we write it as H suffix F. Sorry, specific enthalpy, we write it as H suffix F. Similarly, the specific entropy, we write it as S suffix F. Similarly, the specific volume, we write it as V suffix F. So the properties at fluid phase we write using these subscripts HF, SF, and VF. Suppose if a fluid property changes from the fluid phase to the vapor phase, from the fluid phase to the vapor phase, then we write, or subsequently we write it as Fg. So what is this Fg? It is the difference between a saturated liquid and dry saturated vapor. So when the fluid is in this particular stage, that is conversion from the fluid phase to the vapor phase, subsequently all these properties, how we are writing them, the specific enthalpy, write it as Hfg with this suffix. Similarly, the specific entropy, write it as S suffix Fg. Then the specific volume we write as V. Sorry, the specific volume, it is not calculated. I will tell you the reason when we move to the next slides, especially for this particular phase. So why this is not calculated, just I will tell you as we move for the next slide. Similarly, for the vapor phase, when you go for the vapor phase, there. How the subscripts are being written? Let us see here. So as I was telling you, if we go to the vapor phase, the subscripts are written as G, especially for a dry saturated vapor. So when we are in the dry saturated vapor phase, subsequently, how we write down the properties? Specific enthalpy, it is Hg, specific entropy, Sg, and specific volume for the vapor phase, it is Vg. So these are subscripts. So always remember in mind, if for the properties we are having the subscript as F, means they are in the fluid phase. If we are having subscripts Fg, they are in the from the transformation from the fluid phase to the vapor phase. And if it is G, then it is a dry saturated vapor case conditions. So these subscripts represent these following conditions. Now, apart from this, we need to know some of the things. So let us see here. As I was telling you, we are having some conversion points. As just now I told you also how we make the conversions. As in some of the steam tables, as I was telling in some of the steam tables, they're writing the pressure value in terms of bar itself or in terms of megapascal. So if he has written in terms of megapascal, already I've told you 1 megapascal is equal to 10 raised to 6 pascal, or this can be written as 10 into 10 raised to 5 pascal. So already we know that the value of 1 bar, the value of 1 bar, it is equal to 10 raised to 5 pascal. 1 bar is equal to 10 raised to 5 pascal. So when this is the case, then we get the following things. That is, we can write it as we can write 1 megapascal, which is nothing but equal to the value of 10 bar. So this is very important. So when you are referring to the steam tables, either on the pressure basis, this you have to keep in mind. First important thing is you have to check the column whether the value of pressure it is written in megapascals or in bar. So let us move to the next things which we need to discuss here. So apart from this, another important thing is temperature. So you should know the conversions. If it is given in degrees Celsius, how to convert to kelvins. If you add the value of 273, it gets converted to the kelvins. Now, as I was telling you, whenever you open any of the steam tables, the conditions which you need to refer is, you have to refer to the two types of values from the steam tables. That is saturated water and properties of saturated water and steam provided based upon, one is temperature based, another one is pressure based. So depending upon the conditions given in the problem, you have to refer whether to a temperature based column, temperature based subtitle of the properties of saturated water and steam, or depending upon, if he has said that you have to refer to the properties based upon the pressure, then you need to go for the table where the properties are written based on pressure basis. So let us see here now. Now in this, what you are seeing right now on this page, you can see that whatever the saturated water and steam properties are there, they are developed based upon temperature, which means if you observe the first column here, if you observe here, the temperature is taken as reference for the formation of steam. The temperature is taken as the reference for the formation of steam. So keeping this as your reference, other properties have been estimated and they have been tabulated systematically. Now, if you, before we go for a further discussion, if you observe carefully, the value symbol T, it is for temperature. If you observe here, it is written in degrees Celsius. The next is PSAT. PSAT means saturation pressure. Its unit he has written here, megapascals. Similarly, specific volume, it is VF, means specific volume in the fluid phase. VG, specific volume in the vapor phase, that is the dry vapor. Similarly, he has given a specific internal energy UF for the fluid phase. This is for the vapor phase. Specific enthalpy HF for the fluid phase. For the dry vapor phase, Hg. For the conversion from the vapor to the from the fluid to the vapor phase, we have HFG. Subsequently, for even for the specific entropy also, we have SF, SG, SFG. One more important thing I told you, for all these properties above, if you observe here, he has mentioned the units. So you should have always these are the standard things. You should observe these units before you pick out these values and go for the calculations. Only one important thing which you need to notice is regarding the pressure. So always when you are carrying the calculations, keep in mind the pressure. If it is there in the megapascals or bar, depending upon that, you have to make the conversions and go for calculations. That is this part especially. It is if it is in megapascal or pascal. So now the steam tables, as I was telling you, you are referring to steam tables which is written based upon the temperature basis, which means temperature is taken as your reference column. This is using this reference column. All other properties have been estimated. Suppose the question has been given to you that for a boiler, the steam developed is at a temperature of 8 degrees Celsius. For a temperature of 8 degrees Celsius, extract the properties of a steam developed at 8 degrees Celsius from a steam table. So what are the properties now? So at 8 degrees Celsius, so if you observe here now, right now we have taken temperature as a reference column according to the question, and the value he has given is 8 degrees Celsius. Now for 8 degrees Celsius, you have to see here whatever the properties are there, you have to extract these properties from the steam table with their subsequent units also. So previously I was telling you that for all the cases we are having for the properties from conversion to the fluid phase to the vapor phase, but for specific volume he has not mentioned regarding the conversion from the fluid to the vapor phase. Why he has not mentioned? So if you observe here carefully in the steam tables, especially the columns of the specific volume, if you observe carefully here, if you observe the value of Vg, how much it is? 120.829, whereas the value of Vf, if you observe how much it is, 0.001. So the value of one, how it starts after crossing two decimal points, which means the value of Vf when you compare to Vg, it is very less. So value of Vf is very less. That is the reason that we have not written separate column for the calculation of VFG. So the value of VF is very less. That is the reason that we don't have separate column. So it is neglected here even for the tabulation also. So this is regarding how we refer the values from a steam table based upon temperature basis. Similarly, in every steam tables, even there is a steam table based on the pressure basis. So let us see which is that. Now if you observe this particular table, so even the subtitle itself, if you observe carefully, what he has written, saturated water and steam. Now it is, what is the case? Pressure based, which means your first column, if you observe here now, how it is, they have taken a pressure as the reference value, and using this pressure as the reference value, using pressure as the reference value, the other properties we are going to estimate. So what are the other properties? As I have told you, the only change here in this what you are observing is there in the previous case when the temperature was the reference, the second column was pressure. Now here if you observe, the second column is temperature, and again the other properties are the same, that is Vf, Vg, Uf, Ug, HF, HG, HFG, SF, SG, and SFG. So now in this pressure based column, the pressure is your reference value, and the things which you are identifying, you have to take it from the steam tables for your calculation purpose. Suppose now he says that I need to calculate the value for a particular pressure written in terms of bar. So now already if you observe here, it is in terms of megapascal. So from 1 megapascal, it is equal to how much bar? 10 bar. So make the conversions if it is given in the bar, and then go for subsequent calculations. Automatically you will come to know how the values can be extracted from the steam tables using this particular method also. Suppose the question given to you is from a steam table, there is, sorry, the question given to you is extract the properties of a steam developed at a pressure of 0.02 bar. I repeat, extract the properties of a steam developed at 0.02 bar. We need the value at 0.02 bar. So if in the question he has mentioned the bar, but now if you observe your steam tables, what it is in terms of megapascal. So you need to convert 1 megapascal to the bar. So already I have told you the relation. What is the relation? 1 megapascal is equal to 10 bar. So you make the things, and if you see the conversions, nearly you'll get this one, that is this becomes 0.0020 is something what it is 0.2 bar, 0.02 bar. So now at this value of 0.02 bar, you need to extract the values from the steam table. That is these properties, all which you are seeing here, we extract this from the steam table and use these values for our calculation. These are the things. So only thing is, always for your purpose, you have to refer the steam tables based upon the temperature basis or on the pressure basis. So how you can decide? Reading the question given to you very carefully, whether it is on the temperature basis or on the pressure basis. These are the things you need to understand. So these are some of the links where you can download the steam tables in the PDF format. You can use these following links. Using this, you can download the steam tables, and depending using the steam tables, you can go for solving the problems. So in the next session, we will be discussing regarding some of the problems where you can take the as a reference of your stream tables and you can extract the values for carrying out the calculations. If you have any queries, you can send me an email to my email ID. So I will reply you through that email also. Thank you, students.